So recall that in the previous video, we talked about annuities, and then I used an example of moving a stream of annuity payments to the future using the future value of the annuity calculations. Now, it turns out that we can do the same thing. We can move the money, or we can calculate the present value of a stream of annuity payments using that present value of factor for annuity formula, which is given to you at the top left. 1 minus 1 over 1 plus I raised to the power n, the whole thing divided by I, as opposed to the future value factor for annuity, which is given there to the right, and that is the 1 plus I raised to the power n minus 1 over I. So depending on what the problem is asking us to do, we can then calculate either the present value of annuity, which is PVA equals cash flow. Cash flow, again, remember, is a typical annuity payment in that stream, assuming equal annuity payments, of course. The cash flow representing one of those payments multiplied by the appropriate factor, which when we are doing present value would be the PVFA formula, which you see there on the top left, or the future value of annuity is simply cash flow times the future value factor for annuity using that formula to the top right. Now, let me also be clear. You don't always have to every time compute these factors, these present value factor, the PVFA or the FVFA, because A, there are tables that do this for you for any given I interest rate and n number of annuity payments. You have these values calculated for you. So it's a simple matter of reading the right table, picking the right number, and then multiplying the cash flow with it. So the same thing goes for the future value factors as well. So there are these tables that are on in terms of I's and N's, different interest rates and different annuity payments. And you can look up the value simply and calculate it. Also, all financial calculators will have these programmed in. So all you have to do is to put in the I's and the N, the I value, the interest value, and the N, and it'll compute the factor for you automatically, which you can then use to solve your problem. So that's sort of but it's good to know always, and I stress this to my students, that you should know what your calculator is spitting out at you, because then you don't get you will get blindsided if sometime you have to compute something and you don't have your handy dandy financial calculator with you. You'd be lost if you didn't know what the underlying formula happens to be. And that's why I always stress that when you're learning this stuff, it's better to know the formula so that if push comes to shove, you can always build it from first principles and solve the problem rather than being totally dependent on your calculator or the table. It's an analogy, as I can't help but sharing this with you. It's like learning to drive. When you guys, and a lot of you may have just learned to drive. When you learn to drive, you can learn either with your standard shift or with an automatic shift car in this country. And when you learn, for example, with an automatic shift where there's no clutch involved and it's just simply a matter of turning the gear to drive and then driving, you may not understand the nuances of operating a clutch. And if someday you are forced to drive a stick shift or a standard shift car, you'll be lost because you have no idea how to change gears, how to press down on the clutch, etc. But by the same token, if you learn to drive the hard way using a standard shift, then you can make the transition to automatic shift without a second's problem, because you know how to drive, having learned the hard way. And it's the same story here. If you learn to solve these problems the hard way using these underlying formulas, then you would have no problems in switching to a table or to a calculator or any other way as the occasion demands it, and you'll be absolutely fine. So here's an example that illustrates this. There's a sequence of cash flows that are occurring. So you can see there are two annuities involved in this. There is an annuity of $800, a 4-payment annuity of $800 occurring at each of times 3, 4, 5, and 6. And then there is a $400 annuity stream consisting of 5 $400 payments occurring in each of times 7, 8, 9, 10, and 11. And we are asked to compute the collective, the present value of these cash flows at time zero. Obviously, when we say present value, it's at time zero right now, assuming a 7% interest rate. So what we do here, and I've given you the answer so that you can check your work, but is to treat these as two separate annuity streams and bring them back to the present and then sum them up at time zero, because as I said, cash flows at the same point in time can be safely added together without any problems. So to use the present value of annuity formula to the $800 stream, your I will be again zero point zero 0.07 and N will be 4, because there are four $800 streams. So when you calculate the present value of this annuity stream, it will be located one period before the start of the annuity stream, which in this case will be time equals 2, time 2. So when you have that brought back to time 2 in terms of present value of annuity equals cash flow, which is 800 times the present value factor, that single sum is located at time 2, which you'll then need to use the single sum formula to bring back to time 0 by discounting in 2 periods. So that'll be the first part of the problem. And then the second part of the problem is to take the $400 annuity stream and then move it back using the present value of annuity formula, where the cash flow is 400 times the annuity stream, N equals 5, I equals 0.07. That equivalent sum is going to be located one period before the start of that $400 annuity stream, which is in this case will be T equal to 6. And then that sum will need to be further moved back to time 0 using the single sum formula that you've already seen. Then when you add up those two at time 0, you should get somewhere in the neighborhood of 2963, which is your present value of those two annuity streams currently. And I encourage you to try it out for yourself and get that answer. Good luck.